Hi there, I'm Andrew Bonnell, and today we'll take a look at experiment of physics 114, uncertainty of a blinking light. This experiment is pretty straightforward and it starts to get our head around physical measurements. In the lecture, most problems are perfect. You come out with exact answers, or you have to round the decimal to so many. Here, every measurement has an uncertainty. Whether I measure it with a ruler, or I measure it with a stopwatch, or I measure it with an electrical meter, like a multimeter. Every measurement has an uncertainty. And our goal in physics lab is to really understand those uncertainties. For today's experiment, we're going to be using the Blinky Light app, and that's on the desktop. And on the desktop, there's a folder called 141 Progs, and in there, just below the folders, there's one called EJS Blink Part 1, 2. And when you open it up, mine opened up on the other screen. I'm going to drag it over there. When you open it up, there's this little blue light, and when you click play, it's going to turn red for a very fixed amount of time. That fixed amount of time is based on this slider. So if the slider's down, it's going to be faster, and if the slider's up, it's going to be slower. Slower as in how long, or the period is going to be long, is really what I should say. And we're going to be taking 25 measurements of this blinky light, and then we're going to do part 2 where we're going to adjust the slider. Now, if for some reason you change the slider, let's just hit reset, and it will change it back to 20.68, and I'm going to go ahead and hit play again. Don't worry about the pin up there. It's not needed. And so I'm going to get ready to time my first one, and I did. I got 2.87. 2.87. Now, when I typed in 2.87, that's based on that slider on the side. And a little note about uncertainty about this stopwatch. It has an uncertainty of 0.01 because that's the smallest digit of the stopwatch. You can't really say the stopwatch has an uncertainty of 0.05 unless it actually shows 0.05. So the equipment limitation is 0.01 seconds, and my ability to use it isn't that as good as 0.01 seconds. Mine is usually around 0.03, 0.04, depending on how focused I am. And so, as part of today's experiment, you're going to figure it out. Now, if your uncertainty, your stopwatch or timing app or phone app had a 0.001, then that would be the uncertainty of that device. And I'll bet you won't be able to have the same kind of uncertainty as 0.01. We just aren't that fast. We have some delays from our brain to our hand. We have some delays from our eyes to our brain to our hand to do things. I mean, our mood and focus changes. How much coffee we've had, how much sleep we've had, and if we've had lunch. So a lot of factors make humans bad measuring devices. But we're going to see what our abilities are today. And so I'm going to go ahead and type in this number right here into the cell. I'm going to say 2.87. And I'm going to reset it. And I'm going to get ready for another measurement. And anytime, there we go. And I got 2.97 that time. I'm going to type that in for the next one, 2.97. And rather than showing you 25 different measurements, I'm going to go ahead. I pre-took these data points, and I'm just going to get ready to take my last data point. And I got 2.90. Okay, so I have 25 data points, and we're going to find the statistics on a sample of 3 and also a sample of 10. So to add in another column, I could like right-click and do that. But the easiest way is just right here, this Add New Column button. It's just right there across the top. It looks like a little plus and a little column, Add New Column. And so we're going to take a sample of 3 and a sample of 10. They also both have units of seconds. Oops, I hit cap lock. Lowercase, lowercase. And now down here to take a sample, here's a little bit of spreadsheet notation, which is new for this version of Origin. We can just simply type in equals A and then type in 5. A5. And that's going to be the 5th measurement. Notice 2.88 and 2.88. Now for my next one, I'm going to say equals A10, and I'm going to say equals A20. And there's just a sample of data. Next, for this next column, I'm going to do a different formula, and I'm just going to take a quick little chunk of data right from the middle. So I'm going to say equals A11, and then I'm going to highlight the cell, and I'm going to drag down the corner until I have 10 measurements just like that. And so there we go. We got 10 measurements. Now I want to rearrange these 3 columns so that I can have it in better order, so I can have a pretty table that goes smaller, bigger, bigger. Okay. So now to do statistics on column, you can highlight this and do statistics, descriptive statistics, statistics on column, open dialog. But the easy way to do it is just highlight those 3. And next to that plus column button, there's the statistics button. And you click on that, and it opens up the dialog automatically. I can click recalculate to auto. And typically when you do all these functions, you want to auto calculate in just case you have to just change one thing because you had a typo. Then you're going to do to quantities. And here, the only things we're going to really want is the mean, the standard deviation, and the standard error of the mean. But I'm going to include the total too. I don't need to worry about the sum. I can click on quantities, and I can uncheck all that stuff. But you don't have to really do all that. You can just have these top, and then you'll just take the data out that you want to keep. And my screen resolution is too small for the video, so I'm going to click back to input so I can hit OK. Otherwise, the menu is off the screen. I'm going to hit OK, and I'm going to go look at the report. Now here's the report, and I'm going to zoom in just a little bit. And so my mean, I have 3 different means. I have 3 different standard deviations. I have 3 different standard errors of the mean. The standard deviation looks the best because it's the smallest. But you really expect the standard deviation to be the same for a set of measurements. You don't expect the first measurement and the last measurement to be any different. As long as you stayed focused and we're ready with the tools at hand. Here, because I have a very small sample, I have a smaller sample deviation just because it's kind of like rolling a 7 with dice. I mean, just by chance, I got a smaller standard deviation. This middle one is a little bit more like my typical standard deviation, maybe a little bit better today, because I started out a little bit shaky, and then I was a little bit more focused, and then down here I was getting a little bit tired of taking measurements, so it got a little bit worse. Now the standard error of the mean is simply the standard deviation divided by the square root of the total. And so you would expect that to go smaller and smaller. Here we divide by the standard deviation by 5, and here we divide the standard deviation by 1.732, or the square root of 3. Okay, so we're going to make a nice table for our turn-in. So I'm going to do Control-C. I'm going to come back over here to the first tab. And I'm going to add another column. And just in the first row, I'm going to do Control-V. So there's the total, the mean, standard deviation, and standard error of the mean. I'm going to click on the last tab this time and highlight the data in there. Control-C. Go back to Sheet 1. Right under there, Control-V. And now we got some data. Now we also have to add in a few more columns. So I'm adding in 3 more columns. We're going to have to do some more comparisons. And so I'm going to do expected. I'm going to do units. And then I'm going to do z-score. A z-score is what? Yes, the z-score or standard score is a metric that quantifies how close your mean is to the expected value within your uncertainty. And so we'll calculate what those are. Now the expected value, there's a proportionality constant of 1/7. And so you look at this value right here and you say, what is that divided by 1/7? Because I kept the slider the same thing, same each time. So I'm going to see equals 20.67 divided by 7. And I get a value of 2.952, etc. Now the units for all these is just going to be seconds. And yes, the mean has units of seconds. The standard deviation has units of seconds. The standard error of the mean has units of seconds, and the expected value has seconds. But these aren't rounded correctly. They're not rounded to a rule of 1 and 2. What does a rule of 1 and 2 mean? It means that this is the standard error of the mean, and so we need an additional digit because it's a 1 or a 2. And so we highlight those cells, we right-click, we format cells, we scroll down a little bit and set decimal places, and we're going to set the decimal places to 3 here. And click OK. And you're going to say, well, but it has a 0. I don't need to include that. Well, for measurements, we do actually include that 0. And these 2 zeros are important too. Now for the next row, I'm going to highlight the next. Actually, I'm going to look at the next 2 rows and see that it's an 8 and a 9. And I'm going to round both of those to a rule of 1 and 2. I'm going to format cells. And once again, set decimal places. And this time, it's 3 again. Hit OK. And there we go. So we got all our values ready. Now our z-score is the absolute difference between our mean and our expected value divided by the standard error of the mean. So it equals ABS, this one minus, oh, I can't select the cells like that, Control Z. I have to actually type in the cell reference. So I'm going to say equals ABS, and I'm going to say E2 minus H2 divided by G2. And I can drag that down. And really quick, 5 is really big, but before I talk more about it, I'm going to decrease the digits. Format cells. I'm going to decrease the digits for a rule 1 and 2. Or sorry, not a rule of 1 and 2, just for a couple digits. We don't need lots of digits for z-score. Sometimes you find internet tables that have like 5 or 6 or 8 digits, and you don't really need that many. Okay, so even though my standard deviation was really good because I was lucky, it had only 3 samples. So my standard deviation was really small, and that actually hurt me because my average of those 3 values was pretty far from the mean. You're going to say, no, it wasn't. It was 2.9 versus 2.953, but compared to the standard deviation, it was really far. And so that's not a significant value. Now my second was actually pretty close to my typical, maybe a little bit better than my typical uncertainty. And I got a z-score of 1.8, and that's pretty good. You typically shoot for a 1. Sometimes you are okay with a 2. And when you do real science, you want it as close as you can. And good measurements are hard to take, and that's why science is hard. And then I told you I was getting lazy again, and so my z-score for the last little bit wasn't as good. Now if you were just to copy these values and paste them into Word for your table, it's not going to come out as pretty because it's going to forget where you rounded, and it's just going to mess some stuff up, and it's going to tabulate it differently. And so instead of doing that, what I recommend is just doing a screen snip. And so I'm just going to open up screen snip, and I'm going to do new. I'm going to go around the box right there, and I would do Control C, Control V into Word, and that's good. Okay, and now let's move on to the second part. For the second part, we're actually going to be moving the slider up and down. And if you move the slider down, you're going to see that it's pretty quick. And so as it turns red, it was less than a second. And if I slide it up, it's going to be pretty slow. It's going to be several seconds. And so I'm going to get ready to take a measurement. And I got 0.69 when my slider was 4.86. I'm going to type in 4.86 and 0.69. I'm going to clear that, and I'm going to go all the way to the other end, all the way on the long end, just so you could see that there's a really different slider. So it goes all the way up to 42. I'm ready. And it's going to be red for a while. I'm ready again. And I got 5.97. I come over here and type in 42 and 5.97. Now we're going to go find out we're going to plot this and find out what our standard deviation is, but we start out with our best guess of our uncertainty. And the best guess for uncertainty was the standard deviation, which is the uncertainty for each measurement, that for my 10, it might probably not quite as good, but I'm going to start out with it. We'll see that it might get a little bit better or it might get a little bit worse. So 0.26 seconds. Also, when you plot, you need an X, a Y, and a Y error. And so to change the second column from a Y to a Y error, there's this fun button up here that you can just change it. Also, when you first select the column, this little menu pops up, and you can set as Y error. Or if you want to dig through menus, you can right-click, set as, and dig down for Y error. I just recommend using the fun buttons up there. Okay, now to plot it, you're going to select the 3 columns and then hit the 3 dots down below, but I'm in the way. Hopefully you can see the 3 dots. And you click the 3 dots without the line, and we got 3 dots without a line, and my error bars look way too big, and I think I forgot to type in an extra 0, so 0.26. There we go. Go back to my points, and now my data, I can't even see the error bars. So for most of your graphs, make sure that error bars or the points are set to like 0.3 or smaller, or 0.1. Okay, so now I see some error bars. I see that some are a little higher, some are a little lower. If I eyeball where a line would go, I'm gonna do analysis fitting linear fit open dialog. And this is different than a Microsoft trend line. Microsoft trend line says, well, you thought you know what the uncertainty was, but I don't care what you thought the uncertainty was. I'm just going to calculate my own uncertainty. While here, Origin lets you choose what your uncertainty is, and you should have a really good understanding of what your uncertainty is by the end of this semester. And so it actually calculates, it does a regression of what the line actually is based on the uncertainties and based on the measurements. While Excel just kind of says it looks like it's going this way. And that's two different things. So the first thing we do is we set it to auto, and then we go to fit control. And we come down here to the option that says scale error with reduced chi-square. We uncheck it. And then we go over here to residual plots, and we uncheck everything else. Now there's one more thing that we have to check or change, and that's back under fit control. You're going to first fit this without an intercept, or sorry, without fixing the intercept, and then you're going to be fixing it to intercept to 0 because that's the correct model. So we're going to fix intercept at 0. We're going to go ahead and hit OK. And if you notice, it created a report box that fit a line. We're going to hit OK. And before we look at our results there, I'm going to scroll down and look at the residual plot. And the residual plot looks more or less random. If I eyeball it, we're looking for 2/3, and I see roughly 2.5, and so it's pretty close to what I had. From here, we can go either back to here and do the statistics of this column, column D, regular residuals, and if you didn't uncheck those other boxes, you'd have lots more data out there. You just select that. Or, better yet, you can just come to the report down here, and we could just do statistics on the graph, statistics on the column, because these points represent data in a graph, and so we're going to do statistics or data in a column. So we're going to do statistics on the graph, and we're going to do auto and quantities. We can uncheck all of them, but the standard deviation if we wanted to, or we can just have all the boxes standard, and then only copy and report the standard deviation. So I'm going to look at the report, and here it is, 0.031. So my standard deviation actually got a little bit better. And so we can copy that, and you can also paste that into, you can write it in your diary. And we can come over to our first tab, and we can change this right here, Control V, to that number. That really rounds to 0.03. And so then we can come over here, we can move this down over there, and we can double click here, and we can start editing the table. Now we don't need all this information down there, so we can delete it. But when you do it that way, it doesn't delete those extra rows. I do need a row for stdev, standard deviation of the residuals, and so I'm going to so 0.03. But to delete these extra rows, I'm going to highlight the rows over by the 7, 8, 9, and then I'm going to delete rows, right-click delete rows. To make the table a little prettier, I'm going to double-click between the two columns. I'm going to add in a column, and this one I'm going to say expected. And the expected value is equal to 1/7, 1/7. Now I could round this one down just one digit, I think. Nope, I can't because that's a 3, it's a 4 to the 4th, and so it has 3 zeros and a 4. So I have to leave those digits just like it is. And with mixed numbers, it's hard to read. That's one thing I don't like about Origin, is it wants to give you more digits for the uncertainty, even though you don't need them. But I'm going to add in another 2 columns, and the next one's going to be units. And the units are seconds, and don't forget the units for the standard deviation of residuals is also seconds. The reason why the slope is seconds is because the x is arbitrary. So it's seconds divided by no units. And I spelled it wrong, but that's okay. Don't want to, and then finally a z-score. And what is my z-score? I got to type in the value this time. I can't say B5. I have to type in 0.014139 and minus, this time I can, C5, I forgot to do ABS, so I'm going to add in those parentheses, ABS. Then I'm going to click at the end, and now I can divide it by 0.0004. That's what it would round to. And it looks like I typed in one extra zero there. Yep. And so I got a z-score of 3.66. That's not very good. Not very good. It means that I was taking kind of precise data because my standard deviation of the residuals was small, but I was making a systematic error where I was making them all too small. Notice how this number is a little bit smaller than this number. You're going to say, well, it's not that much smaller. This is a 14139, and this is a 286. It's not that much smaller, but it is smaller based on how I was taking the data. And so in this case, I was really focused as I started, and then when I stopped, I wasn't super focused because I didn't expect it. Anyways, you're going to update table, go back to graph, where we can move this table down here. And if you wanted to make it a little bit bigger, if you hold down the control and drag the corner, it will drag it proportional. Now where we can add a title, you can click the little T on the side. Oops. You can hit the little T on the side and say finding the proportionality constant. C is equal to 1/7 of a second. Now, instead of snipping this one out and pasting it into Word, it looks much better if you export it as a GIF or a JPEG. And so go over to File, Export Graphs, and Open Dialog. A ping is even better than either of those. The instructions say JPEG is fine. Save it to the desktop, and long name is fine. And now I'm going to go ahead. It says replace it, sure, because I practiced this once already. I'm going to open it up, and it's going to open up over here, and there we go. There's my graph. Now this is really easy to add to a Word document, and then write a few things based on what the bullets say. And that's about it for this experiment. Thanks for watching.